All right, let's get right into it. Today, we're tackling a beast, Approved Document L. If you're in UK construction, you know this is the rulebook for energy efficiency. And honestly, getting this right isn't just a good idea, it's absolutely non-negotiable.
So let me just ask you straight up. Are you 100% confident your next big non-domestic project, your office, your warehouse, is going to pass the legal requirements for energy performance? Because this isn't just about being green. It's about staying on the right side of the law.
And that really gets us to the heart of what we call the Part L challenge. Part L of the building regulations is basically the government's master plan for creating buildings that are actually fit for the 21st century, high performance and low energy. Approved Document L is the map you need to navigate it. Now, first thing to know, Part L is split into two books. Volume 1 is all about dwellings, people's homes. But today, we're diving deep into the really complex stuff. Volume 2. This is for everything else, from giant factories to your corner coffee shop. Okay, before we go any further, you have to understand this one sentence. It's pulled right from the document itself, and it's a huge deal. It's basically saying, this guide is essential, but it can't cover every single unique situation. So what does that mean for you? It means the buck stops with the project team. You, the designer, the builder, you are ultimately responsible for making sure the building truly complies. So let's see how this actually works, starting right at the beginning, because your path to compliance begins way before anyone even thinks about digging a foundation. It starts on paper, with your design targets. This is the performance blueprint your building must hit. For any non-domestic building, your first major target is the target primary energy rate. Now, this isn't just about the energy the building uses. No, it's way bigger than that. It also includes all the energy that was lost just generating the electricity and getting it to your site. It's a true whole system metric. And number 2 is the target emission rate. This is the literal line in the sand for your project's carbon footprint. For non-domestic buildings, these are your two big goals. It's interesting to note that for homes under Volume 1, there's actually a third one, the Target Fabric Energy Efficiency Rate, which puts an even heavier emphasis on the quality of the insulation and build. So, how in the world do you prove you're going to hit these targets? Well, it's all about a comparison. Using official software like SBEM, you model your actual building design. Then, the software creates a notional building. That's a version of your project that only just scrapes by the minimum standards. Your job? Your design has to be better. It has to outperform that baseline. Okay, Blueprint is set. We're moving from the computer screen to the construction site. And the very first thing you've got to get right is the building's shell, what we call the envelope. This is your number one defense against wasting energy. We measure the performance of the fabric using U values. And remember, the lower the number, the better the insulation. And as you can see, the standards here are really tight. A wall, for example, can't be any worse than 0.26. And let's be clear. These aren't just goals to aim for. They are hard limits, absolute backstops. But look, you can have the best insulation in the world, but it's completely useless if your building is full of drafts. And that's where airtightness comes in. The absolute maximum leakage you're allowed is 8.0 cubic meters of air per hour for every square meter of envelope. And to give you a sense of what that means, they test this at 50 pascals of pressure, which is kind of like having a 20-mile-per-hour wind hitting the building from every direction at once. All right, we have sealed the envelope up nice and tight. Now it's time to talk about the machinery that goes inside. We're shifting from the passive elements to the active systems, the things that actually provide heating, cooling, and light. Now, as you'd expect, the rules for these systems get tougher as the building gets bigger and more complex. So what happens when you're working on a project with a really powerful heating or cooling system? The requirements ramp up a lot. And here is the magic number you have to burn into your memory, 180 kilowatts. If the total power output of your heating or AC system goes over this number, you're legally required to install a Building Automation and Control System, or BACS. This is a massive step up from what you'd see in a typical home. And a BACS isn't just some fancy smart thermostat. No, it's the building's brain. It has to be constantly monitoring, logging, and analyzing exactly how energy is being used. It needs to be smart enough to spot when a system is starting to lose efficiency and then automatically alert the building manager to get it fixed. It's all about data-driven performance. So you've nailed the design targets. You've built the envelope and installed the systems to spec. You must be done, right? Not yet. Now you've reached the final boss,
proving that the building, as it actually stands there, performs the way you promised it would on paper.
The process for this is pretty clear. It's a 4-step journey. First, you submit your design stage report. That's called a Bruegel report. Second, if your building is over 500 square meters, you have to do a real-life pressure test to check the airtightness. Third, you have to formally commission all the services to make sure they're running correctly. And last, you submit your final as-built Bruegel report with all the real-world data plugged in.
And one last thing, and this is a big one for anyone working on existing buildings. If you're doing a major renovation on a building that's over 1,000 square meters, you might trigger what are called consequential improvements. This means you could be required to upgrade the energy efficiency of other parts of the building that you weren't even planning on touching. It's a key thing to watch out for. Okay, let's pull all these threads together. We've gone from the design targets on paper, to the building fabric, to the high-tech systems, and finally to the compliance process. So what's the real takeaway here? What's the bottom line?
Here it is. It is so easy to look at Part L as just a bunch of red tape and hoops to jump through, but that completely misses the point. You should really see this as the blueprint for creating assets that are actually fit for the future. I mean, an efficient building is cheaper to run, it's a better place to be, and at the end of the day, it's a more valuable property. Simple as that.
So I'll leave you with this to chew on. Regulations are only going to get tougher. And energy prices, well, they aren't going down. So is your next project just designed to scrape by today's rules? Or are you creating a building that's genuinely ready for the energy landscape of tomorrow? Honestly, getting this right is the difference between creating a liability and leaving a legacy. For more videos that get right into the technical details of the building regs, make sure you check out the Building Regulations Copilot channel on YouTube. And if you've got any specific questions, your best bet is to head over to buildingregulationscopilot.com.